Hi, good afternoon, everyone, and welcome to Quantum Conversations. It's here, there, and everywhere. My name is Debbie, and I'm the producer of In the Ether, a festival of quantum science and technology, and also from the public programs team here at ArtScience Museum. It's wonderful to see all of you here, scientists, artists, technologists, educators, and curious minds, all gathered to explore the fascinating world of quantum science and its cultural resonance. Quantum Conversations is one of the many programs as part of the In the Ether Festival that aim to open dialogue around one of the most transformative fields of our time. To begin, it is my pleasure to invite Ms. Harger, Vice President of Attractions at Marina Bay Sands and ArtScience Museum, to say a few words. Honor, please.
Thank you, Debbie. Well, good afternoon and welcome to Quantum Conversations. It's a pleasure to open this symposium, which is, as Debbie said, a key event of In the Ether, a festival of quantum science and technology. Today, we join the global community in marking the International Year of Quantum Science and Technology, a celebration of a field that's transformed our understanding of reality. A century ago, scientists first glimpsed the strange rules of the quantum world. They discovered that light could be both a wave and a particle, that particles could be entangled across vast distances, and that uncertainty was built into the fabric of reality. Those discoveries unsettled everything we thought we knew, but they also opened up extraordinary new possibilities. This afternoon, we gather to explore what quantum science means for us today, in science, in culture, and in the futures that we imagine together. Quantum Conversations is part of In the Ether, ArtScience Museum's festival dedicated to science and technology. This year, across installations, workshops, experiments, and conversations, it brings the mysteries of the quantum world into public space, making them visible, tangible, and cultural. The festival and today's event is a partnership with the Centre for Quantum Technologies and Ethereum Singapore, as well as being a partner event of Switch. And I'm so happy that we have all of those partners with us today. During the symposium, we'll hear from a range of different perspectives from scientists, technologists, artists, and policymakers. We'll begin with Dr. Alex Khoo from CQT, who will take us on a journey through the fundamentals of quantum mechanics. Later on, we'll hear from artist Yu-Chen Wang on how art and science can collide. And later, Desmond from the National Quantum Office will join Genevieve Khoo from SGInnovate to reflect on how quantum science is shaping innovation in Singapore. Many more speakers will help us illuminate the quantum realm today. The uncanny logic of quantum mechanics has been with us for more than a century. In 1900, Max Planck proposed the idea of energy quanta. By the 1920s, Niels Bohr, Werner Heisenberg, and Erwin Schrödinger had formulated the principles of quantum mechanics, ideas so confounding, even their founders were unsettled by them. In 2025, these ideas resurface with new urgency. The year has been designated by UNESCO as the International Year of Quantum, a global invitation for us to reflect on one of the most revolutionary frameworks in modern science. A century after the most perplexing breakthroughs, quantum mechanics still challenges our assumptions about what reality is. It models a world in which uncertainty is structural, outcomes are probabilistic, and volatility is the norm. In that sense, it may offer more than a theory of physics. It can be considered a way of knowing, a mode that acknowledges indeterminacy, embraces relationality, and resists the pull of fixed outcomes. For me, as a curator, this year has been a chance to reflect on how principles that first surfaced in physics have entered the conceptual vocabulary of contemporary art, culture, and philosophy. Quantum theory is no longer just a framework for physics, but a generative model for how we think, create, and live today. The world outside feels at times as though it's no longer behaving in a strictly classical way, so perhaps the principles of quantum theory might offer us a way to think and act within these radically volatile times that we exist within. With that in mind, it felt natural that we would dedicate this year's In the Ether Festival to quantum science. Across these weeks, visitors are invited to encounter quantum mechanics through art, science, and public engagement. At the heart of the festival is our Quantum Science Fair, created together with CQT and in collaboration with the Deutsches Museum in Munich. This is a space where quantum concepts become accessible, understandable, and visitors can explore various exhibits from satellites through to quantum chips and experimental demonstrations that bring abstract principles to life. Alongside this, we're presenting the work of internationally renowned artists. Libby Heaney entangles human and non-human voices into a choir of possibility. Yu-Chen Wang draws on the archives of particle physics to create a poetic meditation on what can be made visible. Semiconductor animate the flight of photons. And Amy Carl, just outside here, uses technology to help us sense the interconnectedness of matter. Together, these projects exemplify what ArtScience Museum seeks to do all year round, to make the invisible visible, and to show that science is not only technical, but cultural. Today's event is part of hundreds taking place around the world in recognition of the International Year of Quantum Science. UNESCO has convened a series of working groups that will provide recommendations on how quantum science and technology should develop over the next 30 years. Significantly, one of these groups is dedicated to arts and culture. It met in New Zealand in July to start drafting a vision document for UNESCO. This event was called Quantum Crossroads. It was a gathering of scientists, artists, cultural leaders, and Indigenous knowledge holders. I was there together with our friends at CQT, contributing to discussions that explored how the cultural sphere can and must play a role in shaping the future of quantum science and technology. Now, this matters because artists and cultural institutions have the power to shape how the public sees. We can help make quantum comprehensible and meaningful. By doing so, we can influence not only how the science is understood, but how it's integrated into society in the decades to come. Here in Singapore, the relevance of quantum technology is immediate. Research centres, startups, and government agencies are already investing in quantum communication, sensing, and computing. These fields are becoming part of our national innovation landscape. Next month at Switch, the Singapore Week of Innovation and Technology, quantum tech will be on the agenda alongside AI, biotech, and advanced manufacturing. This signals how important it's becoming for Singapore's future economy and to the opportunities that are available to young scientists, technologists, and entrepreneurs. At ArtScience Museum, our role is to complement this ecosystem, helping make these developments visible to the wider public. We create spaces where everyone can encounter quantum technology, not only as a technical domain, but as part of our cultural imagination. This work would not be possible without our closest partners in the quantum world, the Centre for Quantum Technologies. I first met CQT in 2014, soon after arriving in Singapore. At the Singapore Mini Maker Fair that year, their scientists were demonstrating superconducting levitation on a magnetic racetrack, whilst one of their postdoc students, Tan Peng Kian, was explaining his discovery of photon bunching in sunlight. Those encounters marked the beginning of a relationship between ArtScience Museum and CQT that since blossomed into more than a decade of collaboration. Together, we've staged film competitions like Quantum Shorts, presented public talks and experiments, and in 2018, mounted All Possible Paths, a major exhibition about Richard Feynman. What I treasure most about CQT is that their commitment has never been about just outreach, but about genuine inquiry, about inviting artists, filmmakers, writers, and choreographers to think alongside some of the world's leading physicists. So I want to extend my warmest thanks to everyone at CQT for walking this path with us, and in particular, Jenny Hogan, whose generosity and friendship have been at the centre of so much of what we've achieved together. I would also like to thank our partners, Ethereum Singapore, Switch, and the Deutsches Museum, as well as the scientists, technologists, and artists whose work animates the festival. And to my own colleagues here at ArtScience Museum, thank you for your commitment to creating spaces where art and science meet. And most especially to Debbie Joseph, our amazing programs producer who directs In the Ether. Debbie, your vision and your sensitivity and tenacity have been at the heart of In the Ether, and we're incredibly fortunate to have you on our team. The physicist Niels Bohr once remarked, "Anyone who's not shocked by quantum theory has not understood it." A century later, the shock is not worn off. Quantum mechanics continues to challenge how we see the world, and that's precisely why it matters. At ArtScience Museum, our task is to make this shock generative, to open space where the strangeness of science can be sensed, shared, and thought through. We don't do this to simplify what's complex, but to invite everyone into the adventure of understanding. We want to generously share what these discoveries might mean for our collective future. Today's Quantum Conversations is part of that commitment. It's a space for dialogue, imagination, and discovery. Whether you're a seasoned scientist or simply quantum curious, we invite you to lean in, to listen deeply, and to ask questions that don't have easy answers, and to embrace possibility. Thank you.
Thank you so much, Honor, for the wonderful words. Thank you so much for setting the stage for today's conversations. Next up, we are honored to hear from Professor Valerio Scarani, Principal Investigator and Deputy Director of the Centre for Quantum Technologies at the National University of Singapore. He might be a familiar space if you have already visited the Quantum Science Fair portion of the festival at Basement 2. I won't reveal too much if you haven't, but just keep a lookout for his friendly invitation outside the entrance to the Oculus at Basement 2 of our museum. Professor Valerio, please.
Yeah, I will keep this short because we have a better presentation on quantum physics coming soon. I wanted to just share an anecdote that I lived 4 years ago in Zurich, having lunch with a friend, a colleague, and this friend told me this. He said, well, we are here, the two of us, among the world experts of, well, whatever, Benlon locality, whatever that thing is. And normally the experts in a field are those who have developed a deep intuition, right? Whether in science or in economics or in politics, you get it, right? And here we are. And the more we think about it, we don't get it, right? It's so weird, so counterintuitive, even for us, right? And yes, I mean, Stefan was correct, right? That quantum physics, even for us, we don't have an intuitive understanding of what's going on, even after studying it, even after publishing many papers. And so when later, just now, Alex will give his talk, and later maybe you explore the exhibit and you read about this. Well, if you don't understand, it's okay, right? And that's my main point. Actually, it's probably the right thing to do. And this is why we're advocating, well, some people are advocating to approach quantum physics with a spirit of contemplation. Just go in there and see look at what nature is doing, right? And this attitude, of course, is shared with the arts, and that's why also it's very good to have collaborations with artistic expression. One of my colleagues, Dagomir, that will be in the panel later, has explored this for many years with his movies. And one of his movies is featured here in the, I don't know exactly what time and where, but features in this exhibit. And many other things have been done. Okay, Honor has already mentioned all that Jenny has done with the quantum shorts and other activities in CQT. So I think that, yeah, really this spirit of contemplation, of coming there and looking at the beauty of this thing, rather than maybe coming with a super rational attitude and try to understand everything. That is the best way to approach this quantum world. That's all. Thank you very much.
Thank you so much, Professor Valerio. Mirroring his sentiment and that of honors as well, the team at ArtScience Museum are truly honored to have the collaborative partnership of the Center for Quantum Technologies in this festival and in all our programs of the past. So next up, we will have our panel discussion, Entangled Expressions, where art and science collide, a panel that dives into how science ideas can be made visible and more easily digestible for new audiences. I will be moderating this session today, and with that, I would like to invite our speakers up on stage for the session. Everyone want to do a quick mic check? Mic's working?
Hello, hello.
Oh, can you hear me? Is this thing on?
Yeah. Dag? Check, mic check. Yeah? Okay, cool. So on this panel today, we're very honored to welcome Dagomir Kaszlikowski, Principal Investigator at Center for Quantum Technologies, whose film Harakiri is being screened as part of the festival's Quantum on Film program. We also have Yu-Chen Wang, whose artwork we aren't able to prove that just yet, but we know is out there, is presented near the entrance of the museum as part of the In the Ether festival as well. And we have Eckhard Wallis, who is the acting curator of the Light and Matter exhibition at the Deutsches Museum in Munich, whose experiments we've adapted from to build quantum science fair in our basement 2 circulation area. Welcome all. So now, some of our audience members here today might not have not experienced the In the Ether festival yet, and which we hope they get the chance to later today. To kick off our discussions today, could maybe each of you give the audience a brief introduction to the work that I just mentioned that we have included as part of the festival? Maybe we'll start with Dagomir. You could share a little bit about Harakiri.
About the Harakiri?
Yes.
I apologize, I had an ear infection, so I'm not hearing very well for now. Hopefully it will pass. So I'm a quantum physicist, and I'm also a filmmaker. I made a couple of films about, in general, but some of them are about quantum mechanics, because quantum mechanics is something that really fascinates me. Of course, because I am a quantum physicist. And Harakiri is a movie about the very core, the very essence of quantum theory. And this essence is very hard to explain because it took me 30 years of intense research to get to the point where I decided I don't understand quantum physics So the movie is an attempt to basically give the viewers a feeling about what quantum theory is. So it doesn't explain what it is, because that's impossible, but it gives you a taste, a feeling, a mood, which I think is the only way to communicate this kind of ideas to people who are not working in quantum physics.
Thank you, Dagomir. So his film, The Harakiri, is actually being screened as part of our Quantum on Film program, and I believe it's being screened on Friday nights in the museum. So if you're here any of the Friday evenings, do come and check it out. It's a free screening. Maybe on to Yu-Chen. Could you share a little bit more about your work?
Hello, my name is Yu-Chen Wang. I liked it very much. Me, just artist, don't have a very long title. I got a couple of images here to show you. Can you guess what you are looking at? What are we looking at here? Okay, it's a black and white photograph. 4 white men are looking intensively. This is an image I discovered from the archive at CERN. And what is very interesting about this image, it kind of shows us this is how we understood how scientists at work. Then that piece of paper where the 4 guys are looking into that piece of image, that's the scientific evidence. So a piece of image is to intend to explain science, but this archival image is to tell us what science is being sort of recorded, or the scientific activity is being sort of documented. But then we are looking at a black and white image, but this is how we understand how scientists at work. But my question is, what about the people who are outside of the picture? And so part of my work is very much about the people who are not in the picture, and who is there deciding how this image is being constructed, how this image is being recorded. But I'm very determined to seek the people who are outside in the picture. Remember, a lot of time, the people are not in the picture. It's not because they were not there. It's just they are not inside the picture. And my second image, this is what I have found in the archive at CERN. So I make drawings, like pencil drawings, and I loved it very much. Like really simple lines, how these simple lines become a kind of record of scientific discovery, or these are the evidence of the science. And what I'm trying to do here is not to explain science. I'm not here also to talk about what these images represent. What I'm very interested in is my journey of beginning to make sense of everything. And so we all believe in science is neutral, but I think in this case, I'm much more interested in where I was and how did I became to be interested, and also how I began to be getting to know more about science. And for me, untrained eye, how this image can tell the story, or how this image becomes a evidence for telling science. And that's what I'm sort of focusing on my work.
Thank you, Yu-Chen. Eckhard, maybe you could share a little bit more about our collaboration at Quantum Science Fair and some of the exhibits at Light and Matter.
Yes, so that picture that you're seeing there, that's actually what that has been, or is the product of my work during the last years, and it's in Munich in Germany in the Deutsches Museum. The Deutsches Museum is Germany's largest science and technology museum, and I've been working on curating and setting up an exhibition with the title Light and Matter, which has the goal sort of to do, not only, so in a sense, some things that you are interested in too, Yu-Chen, in showing the stories and showing the people, and maybe also show the people who are not usually in the picture, and on the other hand, to explain the physics. And this is actually how I ended up in Singapore today, because we were lucky enough to get a contact to ArtScience Museum, and you were interested in our interactive experiments, and so we thought of a way how we could bring them here. Now, we couldn't give our own experiments on loan because we still need them in Germany, but we were happy to share our designs and our ideas, and now we're very happy that our work has an impact that goes beyond Germany. And so the interactive experiments that you can see in the basement, many of these were inspired by things that are in our Light and Matter exhibition. And actually, the two of them that you see in the picture, the one in the front, that's a similar experimental setup to this little Mach-Zehnder interferometer or quantum eraser experiment. And then you see these shiny, colorful wheels, which you can also find in a slightly different version down in the basement. So this is sort of my work and how I contributed to this indirectly.
Yeah, thank you so much for sharing, Eckhard. Maybe we can start with Yu-Chen for today. So we actually chanced upon your work, which has a rather lengthy name. We aren't able to prove that just yet, but we know it's out there. As part of the quantum exhibition at CCCB in Barcelona. And we learned that it was actually developed as part of the Arts at CERN program, the Arts at CERN Collide Award. So for audiences who do not know, CERN is actually the European Organization for Nuclear Research, and it operates the largest particle physics lab in the world. Perhaps, as you've already shared about your work, could you tell us a little bit more about your background as an artist and your practice, and how that got you interested to apply for this commission at this particle physics institution?
Well, so I am an artist. I'm originally from Taiwan, but living in the UK for a long time. And so for me, as a kind of as an immigrant, that sort of life journey become a very important quest for me. How I make my art is I undertake a lot of residencies by going to different places, including CERN, or perhaps like the wetlands in east part of England, for example. So I go about to do a lot of different residencies to different places. So this going somewhere with the mind of like not knowing enough, but I always have a group of wonderful people there helping me to get to know better these places. And so that sort of back and forth, traveling, undertaking residency. There's some sort of little theory I have. It's about landscape. You know, we do not look at, I do not look at CERN as an object. I need to go there. I need to come to Singapore, to be inside the Singapore, to look out from, to be able to see what it's like to be in Singapore. And so by being in this place, by being here, and so I'm trying to make sense of the world around me. And by going to CERN, by looking at how they do the scientific research, and that's how I try to make sense of my work. And so the place, the people, the amazing people who help me to understand better those places. And I guess that's just kind of the basic of how I make my work. And with this, I remember sending the proposal. I made it really clear, not interested in data, not interested in the visualization of the data, but I'm interested in the people behind science. Like this image you can see, well, that's the 60s bubble chamber. It's an old machine, which is redundant. And like earlier we talked about, it's the relics of an old piece of machine. But it is because of those wonderful people out there to help to expand the story. And so then I can get to know more about what happened in those places.
Yeah, that's very cool. I think it's really interesting that, you know, Yu-Chen kind of took the approach of a people-centric approach. I think that's one of the reasons why, as we were curating the In the Ether Festival as well, we wanted to place her work at the entrance, because while you might enter the festival or the museum not knowing much about quantum or physics, you learn about the behind the scenes first. You learn about the people that were involved in them, and we thought that was really impactful for that being placed there. So the work actually was adapted for presentation here. So originally, I'll leave Yu-Chen to share a little bit more about its original presentation as well. It was originally presented quite differently when we saw it at the CCCB exhibition, and it also features dialogue in 3 languages. which is a little bit of a teaser I like to share with audiences when they see the work, and I'll leave her to share a bit more. Could you also tell us, not just beyond, the adaptation and the different dialogue, could you share also like your inspiration behind the work and how you decided on the artwork title?
Yes, yeah. So, Leanne, if it's okay, if you just, show that earlier that bubble chamber is what we see as almost become a sculpture, but this is from the book, and it's actually show the scale. I think the first thing being inside the sun, scale is just phenomenal. It's sort of distorted the way how we understand the world, because simply the machine is just like massive. And also all these different generations of the Large Hadron Collider or the different generation of the detectors, they're essentially just cameras. And so that theory of photography is tremendous. Like you can see on the image on the left-hand side, this is, like the back in the day in the 60s, it's a labor intensive. It literally takes several days to produce one image. And how do you produce an image? If you go to the next slide, please. And if you image produce, so that machine you saw, the bubble chamber, is heating up the liquid to very, very high temperature. And these are the trajectories. I'm not going to explain science because I just cannot do. So that's also the problematic, the problem with the language. And simply for me, I'm constantly looking at the wrong thing. Because with the untrained eye, I say, these crosses is so interesting. But then the scientists say, these are not important. We're always focusing on the wrong place. If we go to the next image. So this is, back in the day, how images being created takes so much time. And there's a lot of women in science. If you go to the next image, like this woman, they were called as scanning girls. Which is really, I find it quite disrespectful, perhaps. There are lots of women in science, but they are not the scientists. Basically, what they do is more like a computational job. It's to calculate from one point to the other, that momentum. So I'm very interested in this unseen labor, those labors behind this scientific research or experimentation, how much work, how much labor. Now it's all automation. Now, perhaps 1 second can produce 40,000 pictures, whereas back in the days, 2 days, 2 pictures. If you continue to the next image, and I love very much, really manually how the curvature is being calculated and be measured, and this endless amount of the labor-intensive work, and which similarly, I myself make a lot of drawings, and in a way, it kind of is really interesting. If we go to the next image, and this is a fantastic woman, Maria Fidecalo. She's sadly no longer with us. By the time I was interviewing her, that's when she was already 80-something. And she started work at CERN before CERN was even CERN. And so that itself, she's almost like the archive. And I love that relationship I have had with so many wonderful scientists, and through their own sort of account to tell me to unpack all these amazing stories. If we go to the next image, and that is Maria when in the 60s in the spark chamber. And this is like a human, where is the human position in this machine, in this apparatus. If we go to the next image, and this is the first generation of my work, first presented in Liverpool. And then if you go to the next image, and that's when it was presented in Barcelona. And so in a way, it's almost like kind of a genealogy, but I think I should totally talk about the title of the work. My title is always very long, like we unable to, but who is this we? And I think that's often is one of my very important questions, because particularly in the scientific world, we have this massive big we, we as a human, we've got to do this, we got to, we're heading this direction. But then the question is, what about me, my voice? Where do I stand in this whole entire narrative? I don't claim that I want to speak on behalf of a lot of people or human. So in the film, I constantly refer to how I change my mind and how I begin to know more. And I think that is a kind of ironic, but at the same time, it's so like we don't know, we can't just prove it yet. So it's a kind of optimism. We're kind of almost imagining, that there is a potential and we still need more time, but we know it's out there. That sort of optimism, I think this is precisely what drives the scientific research continue. Like, why do we continue? Because we almost believe there is a possibility one day we are able to do something. And I guess that's really similar between artists and scientists. Like, we believe maybe we will at some point, but not yet.
I think on the topic of artists and scientists, maybe we can move to Eckhard, who is a scientist. So unlike Yu-Chen, you come from a physics background, which often leads to people to academia or industry. What motivated you to take your expertise into a museum? And how does your experience as a scientist, how does that shape your perspective as a curator?
Yeah, so typically when scientists end up in museum, it's usually the result of an unusual career path. And in my case, so I studied physics, and then I first went into the history of science. And what motivated me to do that is actually by reading books or seeing works very much like yours. And now that I've seen all of these super interesting pictures from CERN, it just makes me want to get more into the history of particle physics again, because all of these huge infrastructures and the stories behind it are so interesting. And I also think you're doing really a terrific job in highlighting the people you usually don't see, and all the extra work that's sort of taken for granted sometimes, that is done by the people who actually did the menial tasks, or I don't know whether that's the right word, well, the routine tasks and so on. Yeah, so that's why I went into the history of science, and then I got to the Deutsches Museum, which is not just a science center where you can experience experiments in science, but where we also collect the material culture of science, the traces of history, and so there was also this historical dimension in our exhibition project. And so my perspective as a scientist and as a historian of science also is, I guess it's very much focused on the real thing and on things that you can actually see and touch. So this is what we have in our collections. We have actual real objects from laboratories with instruments, so you can see what the environment looked like, where the people worked to discover these things. And so we pursue the same approach in our experiments. We try to, whenever possible, to show real phenomena so that people could really have a first-hand experience. So to see something, to see a little light, to see something glowing, maybe also to hear things if possible. So very much in the same spirit as what Alex talked about when he said that quantum physics is real, right? So that was also our idea, to show real experiments where quantum physics is at the basis. Yeah.
Yeah, thank you for sharing. I was just wondering if you could maybe share with our audience, because we keep hearing Light and Matter exhibition, Deutsches Museum. I think what we see in Basement 2, the adaptation that ArtScience Museum has taken, is quite a small scale of what's being presented at the Light and Matter exhibition. Could you maybe share with the audience a little bit more about what is within that exhibition to kind of and how that kind of built the full quantum story that Light and Matter had served to achieve?
Yes, so we were in the comfortable position to have a lot of space and also, let's say, comfortable funding. We have 250 square meters, and the exhibition we have 21 of these interactive experiments, so many more, and we have around, I think, 80 historical objects in our showcases. And so what we basically do is we do a little it's a little narrative through the 20th century. We start in around 1900 with the two models of light, try to show experiments that can convince people of a wave model, or that are sort of, let's say, evidence that a wave model is an adequate description of nature, and other experiments that that point towards a particle model. Sort of the exposition just to get a grasp of the question, what is light? Then in the second part of the exhibition, we get closer to the details of what happens when light and matter interact in spectroscopy. So you saw Alex showed the line spectra. This is great, I can build on your talk. So how do these line spectra, why are they so special? A third section really on the laser, on all the cool things that you can do with lasers and laser experiments. And then a fourth one really on the quantum physics with individual particles, because in a laser or in spectroscopy, there are always quantum processes happening, but it's a lot of quantum systems. So what you see is just the average of a large number. And the sort of the magic, let's say, in scare quotes, happens when you're dealing with individual quantum particles, because then then the questions become tricky. And so that's sort of the last part, again, to show how people actually performed experiments with single particles. And yeah, so sort of give people an idea what this kind of work looks like.
I mean, it's very cool, and I really wish I could come to Munich to see it. It's now closed. Is it still open?
So if anyone happens to go to the Oktoberfest, which is going to happen during the next 2 weeks, then you can make a stop at the Deutsches Museum and visit the exhibition. We're going to close in 5 weeks, in October 26. And then we are going to reopen as a permanent gallery. So for the next, 200 years or whatever, it's going to stand there as a permanent gallery in 2028. And during 2026 and 2028, you can hopefully find a digital scan of the exhibition and have a look at it on our website of the Deutsches Museum. It's not online yet, but we hope that it will be online soon. So it's a bit like a Google Street View visit to our exhibition.
Yeah, I won't be in Munich for Oktoberfest, but I hope to see the virtual gallery online. Now, not forgetting Dagomir. So, as I mentioned just now, Dagomir is actually a principal investigator at CQT and also a filmmaker. So you truly are the definition of an art scientist, belonging right here at ArtScience Museum. So Dagomir is not only a casual filmmaker, his films have actually won awards. But before we dive into them, could you share with our audience maybe how you got into filmmaking?
It's a long story, and it's a short and long story at the same time, like Schrödinger cat, alive and dead at the same time. Sorry, can you hear me? Because I'm not sure. Can you hear me? Okay, I can't hear myself, but... So actually, my father, who is now no more with us, he was a very influential figure in my life, because when I was a boy, we used to watch movies late at night together. He was a sailor, so he very rarely was at home. But when he was at home, it was really grand, because we watched movies. He smoked a lot of cigarettes, right? And was not very healthy. I don't recommend that. But he actually infected me, like for life, like a vampire, with love for cinema. And I always wanted to be a filmmaker, but I grew up in communist Poland. It was not possible. I mean, censorship and political situation was such that I chose physics, because physics gave me opportunity actually to escape that system. But in the end, for me, physics and filmmaking is actually the same thing, because the source of any creation, right, is our inner desire to understand what the cosmos is about, okay? This is what drives us. And because you are here, you also have this desire. And therefore, I don't see any difference between filmmaking and science. It's the same activity. It's just the tools to process the reality and to understand what it is all about are different. Science uses mathematical formulas. This is just the language. Arts or filmmaking, in my case, uses different tools, but the purpose is the same. So the question was how I got into filmmaking, right? It's just because I am curious about the universe. It's the same thing. And I think that that applies to all of you. You want to know what it is, right? You want to know why it is like that, and how it comes to be like this, how it works, right? That's what drives you. You may not know it that way, but it is what brings you here and what actually makes you interested in science and art, I believe.
Yeah, I think it's really interesting. I mean, we have been working very closely with the CQT outreach team, and we've talked a lot about quantum education. I know you have your film Harakiri being screened here as part of the program, but your film Seeing Without Looking, which is one of your much earlier films, was actually one of the reasons, one of the ways that, one of the mediums that helped me understand the principle of superposition. So I just want to ask, like, I think as your background from a quantum, as a quantum physicist, how do you feel incorporating different mediums like filmmaking have enabled education about a topic that you've studied or something that you're more passionate about? Or has your experience as a physicist, with your experience as a physicist, has it impacted your creative decision making when you work on filmmaking?
It's a very complex question, but during a wonderful presentation by Alex, right, who was my student, by the way. So well done. You mentioned a few times that many of those physicists, right, who actually discovered quantum mechanics, they said that you cannot understand it, right? And you also pointed out that many physicists are very cocky, okay, especially German ones in the past. In the past, okay, not anymore. And it is true that quantum mechanics, Valerio also will testify, and he also said this, that we've been studying quantum mechanics for like, what, 30 years plus? And we are not anywhere closer to understanding it than you are, okay? So if you want to explain quantum mechanics in arts, in movies, right, that's not possible, okay? You can have, you can have educational movies, and you can have long expositions, you can have explanations, but come on. I mean, how can you get anything after watching a movie that lasts for 20 minutes or even 2 hours, right? Maybe you will have an impression that you understood something, but you did not. And that's okay, as many people said here already. That's okay. So I think that the only way to convey something about quantum physics via movies, okay? I don't know about other arts. Is just to give you an impression, give you the mood, give you the feels, and give you the sense of mystery. And if after that, the only thing that you get out of this is that you are more curious and you are intrigued, that means I got your attention, and that's all I want. Because you are intelligent, right? After that, if you are driven, you go and explore yourself. And I think that this is the only thing I can hope to achieve, right, by filmmaking. So I don't know whether this answers
it does.
the question.
I guess the additional takeaway is if someone actually learns something from it. But I think, like you mentioned, it's very hard to take away, the history of like quantum physics or like, quantum mechanics or any details to it in that short film that you might be watching. But I think similar to your films, like Yu-Chen's as well, it really is just a medium and an opportunity for people to grow curious, learn more, want to learn more, or discover for themselves a bit more on the topic, be it particle physics, quantum, other things like that. Well, I have a couple of questions that I think I would like to direct to the three of you. So personally, I can quite bluntly share that one of my biggest challenges working on this festival is diving deep into quantum principles and trying to make it digestible for our audience. For reference, the installations and the interactives that we have across our museum are targeted at a younger audience. We do want them to be approachable and understandable for all ages. But I do think in me working on the festival, I found that, you know, these topics can be quite hard to visualize and understand for complete beginners. But I think in all your works, you found a way to make them easy for audiences to understand or relatable through a creative format of presentation. Do you think your work and experience has changed the way you thought about quantum and how you have helped people try to grasp or grow interest in these ideas?
Yeah, so I have worked with so many physicists, and most of the time what they're saying, I just don't understand. And one of which, who's actually, so he was a professor in Liverpool University, and what was most interesting thing he told me is like 95% of people would have given up by now, but you're still here. And I was really excited. Oh my God, I'm not one of the 5%. You know, that idea of not giving up and willing to try and willing to struggle. And I think that's what got me still there. And I think that whole journey is about, you know, if impossibly to comprehend this notion of abstraction. But I think for me, that's quantum physics, right? Or science. But not giving up and willing to sort of hang out with that, you know, not able to understand. But then wait till the bit maybe you can understand. And that's what kept me going. And I think that's something perhaps we share a lot with the scientists. And it is my own curiosity drive me, wanted to continue. But if I can make a piece of art, it's about how I struggle and how my curiosity is taking me somewhere. And I think I want to, as an audience, I want you to be as excited as I am. And so if I found something curious, and that is what my work is about, my work is not about teaching or educating anything about science, it's about how I begin to be even more interested and what my curiosity is taking me somewhere. And it's that journey I'm hoping to take the audience with me and you know, sit with me and travel with me. And I think that's precisely what I wanted to communicate.
So, yeah, during my experience of creating the exhibition, I had the challenge to transmit the topic to people who are not willing well, not necessarily at that point willing to give that much level of dedication to it, because they will spend a nice afternoon in the museum, or they will maybe spend 1 hour or even 2 hours if they're super motivated in the exhibition. And so one of my professors used to say that you don't really understand quantum mechanics, but you get used to it. And that's, of course, actually not good. That's not good when you try to explain it to other people, because you talk to people who are not used to it. So I had to think about it again, and I think it actually did. I took some learnings from it. And so the first one is, so that's also our strategy. On the one hand, show really the real phenomena, show the real things that are there, and just look at and say, look, this is a phenomenon, and even if you don't understand the quantum physics that's behind it, that's maybe nice, interesting, that's maybe a spectacular effect, and maybe you want to understand it. And then you need quantum mechanics. And the other thing about the quantum ideas is that what we try to do is to present them as tools. So they're tools, analogies that help you understand nature. And so as long as they're useful, you can work with them. And when they sort of make you think that you're not understanding anything, then they're not being helpful at that moment. So you pick other tools. I mean, eventually when you master it and when you really keep going and say, okay, now I go back to the parts where I really don't understand anything, and then you can try to dig deeper and deeper. But I think maybe that's not the best point to start. So for a start, it's really the message. These are tools. They are meant to. They have a certain a certain limit of application, and then you can like work with them and they help you understand it, and as long as they help you better understand things, they're doing a good job. And when you're not, when they confuse you, then you should just say, okay, well, probably they're not suitable for this, what I'm trying to understand at this moment.
So, look, what's left? I mean, what does make sense, really, ultimately, right? Money, politics, I don't know, publications, I don't know, good job. What ultimately matters is the mystery that is here. You know, quantum mechanics tells you that reality as we understand it doesn't exist. Quantum particles are not real in the way we think about the money in our bank account, for instance, right? Or this microphone, it feels real to me, but it's made of particles, atoms, that are not real in any sense in any meaning of the word as we understand it, okay? And it's crazy that we see the real world built out of unreal components. And how the hell, sorry, how does it work, right? It's the ultimate mystery, and I think that what keeps me going, right, and inspires me to do science and create is just to know why, right? I mean, very often I fall asleep, right? And before I fall asleep, I think that one day I'll be no more, okay, like all of you, by the way. And then I want to know, before I expire, right, I want to know as much as I can, to grab as much as I can, and understand as much as I can. And that can only be done through act of creation, right? You have to create, you have to be passionate about things, because otherwise it all does not make any sense whatsoever.
I think that's the true beauty of combining the worlds of arts and science. I think as for all of you, you know, the works that you've worked on in your exhibition, Eckhard, kind of use the medium of art to talk about science. Do you think we could ever use the medium of science to talk about art, or like the other way around? So do you think that, I mean, we don't really know much about quantum computers yet. I mean, I personally don't, or the future quantum technologies. Do you think quantum technologies could be a medium to present art, or even quantum computers could be used to create or showcase artistic form?
Maybe I'll quickly just say one sentence, because I will shut up. But you see, the problem is that somehow in the modern society there is this division between, especially in Singapore, by the way, science and arts, right? Oh, I don't want my kid to be an artist, right? Because there'll be no good salary, okay? Or stuff like that. But this is it's really stupid, okay? Because it's all the same, all right? This distinction comes because people think that that quantum mechanics is about technologies. But science is never about technology. Technology is just a bonus. Science is done because for the heck of it. Okay, I don't want to quote Feynman, who said, maybe I'll say it right. I mean, this is NC16 or... so he said that, you know, science is like sex, right? We just do it for the heck of it, not to procreate, okay? And I think that this is the essence of that. So that's why I think that science can talk about arts, and arts talk about science, because it's all the same. It's all about the ultimate mystery.
What are your thoughts, Eckhard, Yu-Chen?
So we actually have an example of a quantum technology that has been used to create art, although it's now called the quantum technology of the first generation, so the laser, so not modern quantum technologies. And that's actually, you can experience that downstairs. There's a little laser kaleidoscope where you use like the diffraction of laser light through like complexly structured glass discs, and then you see like strange interference patterns. And so these beautiful shapes of light, they look that way because they exploit the effect of the coherence of laser light. So laser light is a special kind of light. You cannot create these sort of shapes with a normal light bulb. And it has been used in the 1970s, actually, in two places. So in California by Elsa Garmeyer, who actually then was involved even in starting a company together with a filmmaker, Ivan Dreyer, company Laserium. And Elsa Garmeyer then went on to be a physicist again. So, like she did a career in physics, so she wasn't really an artist all her life, but she had this little excursion into the arts. And at the same time in Munich at the company Siemens, they built a commercial, or like a prototype for a commercial laser system. It unfortunately never was produced, but they used it at the Bavarian State Opera to create like stage designs using interference patterns. And so you can like play laser artists downstairs and like see how science can create new mediums that artists then can exploit and really like explore the aesthetic potential of these kinds of effects.
Yeah, if I can jump in, I don't think I can sort of answer the question directly, but I will answer the question sort of indirectly. A lot of time, what I understand, for example, the scientists are trying to do is to make invisible visible, and so is the artist. We are trying to make the invisible visible, but how do I do that? With assistive perhaps technology or different devices, and these devices could be, you know, the act of art making or whatever technology that you guys employ. But then the idea is, what do we do to be able to extend our senses so I can see further and beyond? But then a lot of time, the seeing and also the looking is not necessarily sort of a literal way, and it's about to know more, to know further and beyond. That there's something that is seemingly invisible, but then, you know, I can imagine it, I can see it, I can visualize it. And I think that's what perhaps the two can actually having this sort of a interconnectedness in between art and science. But it is true. I don't think the world, we do not think about everything is separate. You know, like you just do not think, because the whole world, everything is all sort of interconnected, all bundled up. There's no such a thing as art, this is science, this is geography, this is mathematics. Everything is interconnected, and we ought to think a lot more through that in the interconnectedness of everything. And that would be much more interesting.
Yeah, and I think with that, I'll also like to do a shout out to ArtScience Museum, where art science is one word and not two. But yeah, just very quickly before we move into the Q&A section, perhaps we could just hear from each of you, what's next for you, Dag? Do you have a new film? Yu-Chen, are you involved with more scientists? What's an upcoming work? And Eckhard as well, as there's a future exhibition you can share about? Maybe Dagomir, you want to? Oh, Yu-Chen? Yeah. Okay.
So I'm very grateful to be here in Singapore. Part of the reason is I'm on my way back to Taiwan. So my next project is all about mangroves. I know you guys got lots of mangroves here, and mangroves is this one of the magical plants, hoping maybe we're going to save us for the future. So this is a new project which I'm working on. It's very much looking into this the amazing ability of carbon store of mangroves, and these are potentially one of the kind of the mixing parts in our sort of collective act to combat the climate change, because mangrove might be actually the most interesting way as a natural-based solution to combat climate change. And this is all my sort of next project is all about. And of course, I'm very interested in history of, in particular, the British botanical explorations, under the British Empire, and how plants, how the biodiversity perhaps being actually recorded and also kept studied at Khoo, and this sort of Western-centric idea of knowledge production, and that is precisely what I'm sort of hoping to work on, and that kind of very hyper-local in terms of all these different geographical location here in Singapore or there in Taiwan, but then how that serves as a globalized story, and that's what my new work would be very much about.
Thanks for sharing, Yu-Chen. Oh, Eckhard, maybe?
Yeah, thanks. So I brought a little teaser of what's happening next at the Deutsches Museum in Munich. So it's not my project, but of my colleagues. And it actually resonates a bit with the exhibition A Better World is Possible, which is here at the one floor downstairs, about the future of our world. And in this case, the title of this new exhibition is called Planetary Health. And it's about the idea that our human health is so closely connected and so closely dependent on environmental factors and environmental influences that we can say our health depends on the health of the planet. So my colleagues plan a participatory, co-creative exhibition where everyone can sort of bring in their own experiences. They want to start from everyday examples so that people can explore these interrelations where we experience, for example, I mean, this is something that I personally experienced during the last 3 days, the influence of temperature and humidity on your own well-being. And so these sort of things will be shown and will be presented in this exhibition. So if anyone, again, happens to come to Europe or to Munich during the next year, then you will see it will probably start in the spring of 2026. So I think it's March or April, I'm not entirely sure, unfortunately, but sometime during 2026, an exhibition on planetary health at the Deutsches Museum.
Very exciting. How about you, Dagomir?
So I am actually now in the process of making a longer film, which is a feature film. And it is about a very interesting phenomenon that I would like you to encourage you to check it out later online. It's called the Boltzmann brain. It's a very interesting concept that is related to actually cosmology, and it is going to be a very kind of existential horror film because the Boltzmann brain is such a weird and unusual concept that I really, really want you to check it out later, okay? Because it's fascinating.
Thank you, Dagomir. I think that brings us to the end of the panel. Now we are happy to open the floor for questions. If anyone has any questions for our panelists about what they've shared or any other thing about their practice or work. Yes.
Hi, can I know how the life of a quantum scientist is like? Like, what do you all do in your daily work? Is it like imagining stuff, writing papers, conducting experiments, or is it a lot of coding or applying for grants and based on your interactions? Yeah.
I think there will be a question to Dagomir.
Well,
He was asking the life of a quantum scientist. What is it like in the daily life of a quantum scientist?
it's horrible. It's horrible because, first of all, it's when you do things right, 90% of the things you do are going to nowhere. Of course, you learn something on the way, but you don't get outcomes that you want. So only 10% translates into something that can be published, and you are accountable. So if you don't publish, you perish, okay? And that's the system that we are living in. And I think it's the worst case of this system is in USA, where you really die if you don't publish. In Singapore, it's not so bad, but it's catching up. So we as scientists, we are forced to basically produce outcomes. And that is a good thing because it motivates you, right? I mean, you don't get lazy, but at the same time, it really kills creativity because you have to follow fashions and you have to, you know, do research that interests others. So if you want to do some exploration that is unpopular, then you are risking quite a lot, okay? But apart from this, it's wonderful because every day I meet Valerio over coffee or Alex, right? We haven't met for a very long time recently, but And we discussed, the mystery of the universe, and then I couldn't wish better for myself than this.
Hope that answers your question. If you'd like to learn more about the life of a quantum scientist, we have a Meet the Scientist Interactives video that we've worked with CQT on at our Basement 2 circulation area, which Valerio is the star of. Yes, but there you get to meet other scientists as
That's
well.
That's the man. Yeah,
Yes, Valerio, you
Scarani.
want to stand up and wave? Yes. Yeah, so does anyone have any other questions for any of our panelists? Yes, over there.
Thanks. I teach AI in NUS, and my question is to all three of you about the intersection of quantum and AI. Is AI going to help us understand quantum more, either through art or through science, or is it going to make it more complicated?
Intersection of AI and quantum, or I guess AI and science. What are your thoughts?
Eckhard, do you have any thoughts? Because
As a historian, I always look in the past.
I actually, so there is, well, AI definitely is changing everything, right? At work, I use AI, for instance, to write boring reports. But sometimes I also experiment with AI to bounce ideas and solve some problems. And so far, it's not very helpful, but I also know that there is a new developing field which is called quantum machine learning, of which I know nothing because there are only 24/7, 24 hours, per day. So I can't really comment on that, but I think that people are, of course, exploring the AI using, quantum systems, but I don't know what's the current state of that. So I'm sorry, I cannot really give you like a meaningful answer.
So I spent the past 2 years working with the machine learning data scientists. What we were trying to do is very much using machine learning as a tool to look into the museum's data collections. But the machine learning, the AI can help to look through large quantity of data to flag up the potential interesting or potential problematic entrance, but it is not yet able to be creative. And so if you need a whole army of loads of people to look through lots of data, yes, it is super helpful. But how do we teach the machine how to look? How do we teach the machine how to select? Is still very problematic, because only if we as humans understand exactly what we're looking for, then we can then teach the machine how to look. But if we don't even know what we are looking for, how can we teach the machine how to look? And I think that is the problem, what we are sort of encountering at this stage. I guess it's still a long way until we are able, be more precisely to work out what exactly what we are looking for, and also be able to articulate about it. So then you're able to teach the machine. Until we are able to do that, then I think it's challenging, but it could be very fast if we find the right language. But be able to train the machine, we need to know our own bit a lot better. And so I guess it's go down to the human again, but quantity and also sort of volume, that's not a problem. But I think like at CERN, they're already doing that, how machine can look for the irregularity. So, like every day they collect so much data. And if there's something a little bit different, when you got that little bump, and that's where the machine is going to flag up, okay? And that's what machine learning is helpful, to notice the irregularity. But then you still need a human to kind of intervene. But of course, we cannot process so much data. I guess that's still the division, but this is all I know and my experience. So.
Yeah. Maybe to add a perspective from the, or to add a museum perspective, or add on the museum perspective that you already brought up, is that, I mean, another danger that I see is, or maybe not danger, but another limitation is that AI can only process things that have been digitized. And if you have a museum with 125,000 objects, and then you multiply this by the number of all the museums, and you have countless of pages on paper pages in the archives, it's very hard to actually digitize all these things. So you add another filter that at some point when you get too dependent on AI, you think that everything that does not exist in the AI simply does not exist, even though there are other things that may simply not be accessible to the AI. And I mean, a similar thing happens when you, as a student, get so used to using online databases and online catalogs that this is for historical researchers, is very important, because then at some point maybe you forget to, or you need to be aware to check the physical libraries as well, or the physical copies, just to make sure that there are things that maybe simply have been filtered out by the process of digitization. So AI is not yet able to see and read the real world, only what we feed it.
If I can just add one more thing, just simply think about imagining you want to digitize all your belongings, but in order to digitize them, you need to create categories, right? But how can you analyze? I have a pair of trainer, it's black, it's got white, you know, like you have to analyze the property, the materiality of everything, and it's impossible to do that. And especially in art, you know, in our museum, there's so many different objects, but how do we categorize everything? And that becomes really, really problematic because it goes back to the idea of knowledge production. And that is itself, it's also, again, very problematic. It's totally Western-centric and also limitation of language. So everything needs to be categorized, needs to be labeled, and needs to be defined. And then I guess what hence earlier Debbie mentioned about my film, it's got 3 languages, right? Because of problem, always go back down to language because it's impossible to explain everything. But how do we use a language to explain or define everything? And so I myself, so I'm from Taiwan, so I speak Mandarin, I speak Taiwanese, and I speak English. There's just so many different languages, and how do we make sense of everything?
Yeah.
Maybe just 2 seconds, because actually I came to my mind now that, you see, the problem is that we do not exactly know what's happening in AI, how it reasons, right? That we don't know because it's just very complicated. But the same applies to quantum computing. If you press a quantum computing scientist like Valerio, for instance, or me, or anyone that works in that area, we cannot tell you why quantum computer is better than the classical one. Yeah, we can wave our hands and say, oh, of course, because of this and that, because of quantum entanglement, because of superposition, but actually we don't know. So I just want you to remember that we are building a machine of which we don't know how it works and why it works, okay?
I think that's all the time we have for today's session. So thanking our panelists. We will be taking a short 5 minutes break before we move on to our next session, which will dive into quantum in Singapore, the industry, as well as career opportunities. I believe the time now is 4:09, so if we could come back to the cinema by 4:15, that'll be great, and we'll see you guys for the next session then. So now on to the last session for today. We have Everyday Quantum, the Science of Powering Our World by Dr. Desmond and Genevieve Khoo. The session shares how local startups are translating cutting-edge research into commercial solutions and the career paths emerging within them. So I'd like to welcome on stage Dr. Desmond for the first segment of his presentation.
Okay, I will admit the first two acts were tough acts to follow. Okay, so I would say that while sitting among you guys, watching at the first two parts of the whole symposium, I walk away with the awe that the richness and the huge infinite creativity of humans, of people, of us, okay, in trying to know what's out there, trying to make a sense of the understanding about the world around us, especially in quantum. So, given the two tough acts, I will run through a few things about what Singapore is doing in quantum, okay, and of course, I welcome also questions during the Q&A about the things I'm going to talk about. So I'll start off about a bit of introduction about myself. My name's I'm Desmond. Okay, I'm in the National Quantum Office. I'm the guy looking after international collaboration and talent development. Okay, so with that, I'll talk about the National Quantum Strategy that Singapore has announced. How many of you know is this year or last year? How many of you will say it's last year, announced last year? How many of you say it's announced this year? And how many of you say, I'm not sure? Good, good, okay. So it was announced last year, back in May 2024, by then DPM Heng. Okay, you can see in this slide all the newspaper cuttings and various local media and overseas media that announced it. Okay, but you will say, okay, we have the National Quantum Strategy, but what is it building on? Because in Singapore, we don't usually just announce a strategy without foresighting or even thinking about what's really ahead at a certain point in time. So this strategy builds on more than 2 decades of investments by Singapore into quantum. As Alexander pointed out, CQT was started in 2007, right? And before that, about 5 years before, we had one grant on quantum tech. Okay, that was then also awarded to the founding director of CQT, Professor Arthur Eckhard. And you can look at the timeline. We have, in recent years, since 2017, accelerated our investments, okay, with quantum engineering program. Our office was founded in 2022, April 2022. And then we launched a strategy last year. And we also have a new, what we call an initiative called Hybrid Quantum Classical Computing Initiative, sometime this year. Now, so we have built upon the momentum, more than 2 decades. And why is it in the strategy? 4 things in the strategy, not 3. Usually presentation, you talk about 3 things. We have 4 things. 1, excellence, scientific excellence, right? We want to continue building on in CQT. Second, engineering capabilities. We want to translate the science for Singapore, for the rest of the world. Third, partnerships. We want to partner with companies. We want to partner with companies who want to use the technologies, and we want to get these companies to work with our researchers in Singapore. And fourth, as I pointed out in the beginning of my talk, right, all this will not be possible without people, without talent that we have to train, we have to attract. This first slide talks about, Center of Quantum Tech. Alex has done a very nice slide just now. I can't match the act, but mine is, you can say it's drier, right? But it lays out very clearly our ambition for CQT to be a national center, okay, with the nodes in the various partner institutions, okay? And we don't stop here, right? As I mentioned, there's scientific excellence, and there's also the engineering capabilities we want to build. So for the engineering capabilities, we have from NQO, okay, planned for and initiated these national level quantum programs. these are our focal points for bringing in or driving translational activities. Okay, and you can see here, Alex also in one of his slides pointed out very clearly, 5 of them, if you remember his slide, okay, and ranging from quantum computing, federated foundry, quantum safe, quantum processor initiative, and the quantum sensor program. Of course, these are not done in isolation. These, from the National Quantum Office, we work very closely in partnership with stakeholder agencies, NRF, EDB, Enterprise, INDA, our great partner SGInnovate here today, and MAS. So these are our focal points. And I also mentioned these are not possible without people. So from the National Quantum Office, this is how we see the various levels of how we build quantum awareness, quantum curious, quantum awareness, quantum proficiency, all the way to quantum expert. Okay, of course, even more experts like Professor Valerio, Scarani, and Professor Dagomir. And in the last 2 stages, we have, through the National Quantum Office, we have planned for and are now implementing the National Quantum Scholarship Scheme, okay, to train master's level and PhD level talent. And we have and for those of you who are, thinking of pursuing being a master's or PhD in quantum, the next slide gives you a bit more details about the scheme. It's open to all nationalities as long as you exhibit or demonstrate a strong interest or passion. And the benefits are, full tuition coverage, attractive stipend. We have research allowance that cover the books, computer, and conference travel. Of course, also a paid, for those who are interested, the paid industry attachment. PhD at CQT, master's through at those programs inside our universities in Singapore. And you can find out more details through our website, by the way. We have a website. And through the investments over the years, just now Alex also very nicely pointed. As I said, Alex has done quite a lot, great job, talking about the things that I was going to talk about. The quantum startups spin-offs in Singapore, majority of them came from CQT. Okay, and we have a huge bench strength, quite a good bench strength in Singapore, 300 researchers across more than 50 research groups in Singapore. And the last slide, in summary, this is how we from the National Quantum Office see how we want to build the house in Singapore, the quantum house in Singapore. And with that, I thank you for your time. And of course, please feel free to follow our website, LinkedIn page for latest developments. And if you're interested in our scholarships, we even have a Form SG for those of you who wants to register interest or in the scholarships. Okay, with that, I end my presentation, and yeah, thank you for your time.
Next up, we have Genevieve Khoo from SGInnovate, who will be sharing more about career opportunities in quantum.
Thanks, Debbie. Thanks, Desmond, as well. Desmond's here because we're going to have a Q&A session, so keep your questions for Desmond, less for me. So I'm really grateful to be here today to share a little bit more about some of the opportunities that we have here in Singapore within the quantum space. Some of you might not be so familiar with the quantum space, or that's not directly relevant to you right now, right here. Hang on, we have a little bit more than just quantum as well. So I'm just going to give you a brief introduction of my company, SGInnovate. So we are basically a venture capital firm first and foremost. We are funded by the government, and everything that we do centers around founders, right? So you see founders right there in the center of the Venn diagram. The company is basically split into 3 major pillars. One, obviously, is the investment arm because we are a VC. And another is the community arm because we believe in bringing the community together, right? So If you're following SGInnovate's page, if you're following some of the activities that we're doing, you would realize that we work very closely with partners, interagency partners like NQO, CQT. We work very closely with the IHLs as well, the founders in any of these ground-up initiatives to bring the community together to make sure that there is awareness, there is curiosity, not just within the current sector and the current people in the industry and the technology, but to also instill interest within the next generation and the younger generation, right? And where I'm from, the talent team, that's a major pillar that we have here in SGInnovate, because what we believe in is that you can put in a lot of money, you can bring a lot of founders together, but that does not necessarily mean that your company, your startup would grow, okay? A big part of helping our deep tech startups to grow here in Singapore depends very much on talent, and that's where we come in to fill in some of these gaps through initiatives and programs that I'll talk a little bit more on. So you can see we are doing quite a bit of investments in portfolio companies. The key here is most of our investments are done locally, so we are really just focusing on supporting local deep tech startups. So some of you might ask me what deep tech entails. So if you can see from here, the bottom half of the page here shows some of the technologies that we are quite familiar with, right? We have things like AI. That's what we started off about almost 10 years ago as a company, looking into cybersecurity. Obviously, quantum computing is there. And recently, in the past 5 years, we have been focusing a little bit more on the top half, right? Things on sustainability, agri-food tech, and their health and biomedical sciences. Recently, what we're seeing as well is quite a kind of a mix of technologies across some of this, right? So we were talking earlier at lunch, Honor. We always think about health and biomed tech very individually. You're talking about your pharmas, you're talking about doing R&D, wet lab situations. But in recent years, what we're also seeing is actually an application of quantum computing within the biomed tech sector. So that's something that's very interesting that's coming up very recently. We're seeing how quantum computing is helping to accelerate some of these R&D for the biopharmas as well. So just a little bit of extra information about our involvement, SGInnovate's involvement in the quantum ecosystem here in Singapore. We are one of the major investors in all of the quantum startups in Singapore. The earlier ones, Horizon, if you're following the news earlier this month, they have just announced news of their IPO. We have Entropical Labs, they're working on error corrections. So these are software-related quantum computing companies. And then we move on to Angel Q. We also have Atomionics. Atomionics looks at quantum sensing. So they are looking at lasers trapping atoms. And then they also do have projects on miniaturizing their gravimeter. So very interesting hardware design kind of roles that they have. And Spectra as well. I think someone was asking about quantum communication. We were talking about QKD. That's actually what Spectra does quite a little bit on encryptions. They have satellites as well. I think they're going to launch this next satellite next month in November. So that's something for you guys to keep a lookout on. Now, something a little bit more relevant to you and something that you can take back with you here today, it's what we at SGInnovate have launched called the Deep Tech Central. It's a localized platform and a one-stop shop gateway where you can go in there. Once you've created an account, you can actually get access to quite a lot of things, right? You can get access to courses. So some of you, we've hopefully sparked some interest in quantum. For you today, you can start an account with us and then get on there to look out for causes, to look out for materials that can kickstart your quantum journey. There are e-learning courses as well. Some of them are free, so you can take that as well. Again, because we're not just quantum focused, if you're interested in things like biomedical, you're interested in things like sustainability, energy, or AI, this would be a good place for you to get started on. Now, if you're a little bit further down the pipeline, You've gone through some of the courses, you have quite a bit of qualification, and you're really looking at, how can I upskill myself a little bit more beyond just taking courses? That's where you can apply for some of our programs. I'll talk a little bit about one of our programs later on, but we have quite a few programs that you can check out on, you can sign up for, and then get yourself plugged into the community. And then there's also a couple of you guys who are further down the pipeline. You might hold a PhD, you might have some working experience in the quantum space or in the deep tech ecosystem already, and you're looking for a job. This is also the place where we have a job portal with all the deep tech roles. So it's very much curated towards the deep tech ecosystem. And you can get on there to look out for roles, apply directly, and then get connected with some of our companies there. Okay, so it's really a one-stop shop. Now I'm going to move on to talk about the summation program. This is one of the programs that really is quite interesting for any one of you guys who are looking to explore a little bit about the quantum space. Some of you guys might be doing your PhD, postdoc. You're thinking about, how can I translate research into something that's a little bit more commercial, right? So this is a program that we've started. We've been running this program for almost 10 years now. We're in our 9th year. I'm going to play a little video before I continue talking and explaining a bit of the program, okay?
If you're looking for a traditional internship,
this isn't it.
It isn't? Okay, then what is summation?
Summation is a deep tech apprenticeship program that matches top talent to startups in Singapore.
Which means?
Get your nose out of the books and get hands-on with real-world projects.
What kind of projects?
Cutting-edge projects in niche, up-and-coming fields using tech like biotechnology, cybersecurity, IoT, quantum computing, robotics, and more.
Yeah, but how much will I really get to do?
We're never backseat players. We take charge. We're asking the big questions and making an impact with the real-world product.
But what if I make a mistake?
Oh, you will fail. We're developing new processes and applying new research.
So, of course we are going to fail.
Over and
over again.
And every failure is a stepping stone to a breakthrough.
What if I've never learned this stuff in school?
Just learn from the job, from the guys who know their stuff.
But why Singapore? Why not somewhere else?
Because you want to be where the action is.
Singapore is a global startup hub where deep tech is growing and thriving.
But how can I be sure this is right for me?
Well, if you want to be part of a passionate, like-minded community,
apply deep tech to real-world problems,
and shape the frontiers of tomorrow.
All right, my favorite question to ask the audience is, anyone spotted me in the video? I was. I'm not part of the people who are doing real work in the lab. I'm a bit more on the fun side, so I was the people in the partying scene, on the rooftop party. That's what we do quite a lot as well. So it's not all boring, work. There's quite a bit of fun on the program and with our startups as well. Okay, so back here on the summation program, it's really a 3 to 6 months apprenticeship model. We place you with one of our deep tech startups, and we're giving you the opportunity to have unparalleled mentorship with the technical people in the office, right? Because they are startups, most of the time you're working directly or almost directly with the founder themselves, the CTOs, or at least a CTO minus one. These are people with credentials behind the technology that you are participating in, right? And how do I know that? And how I can say that out loud here is because my team and I, we are people who go through, the mentors, CVs. We ensure that the people that you're being mentored under are actually people with the right credentials and qualifications. So that's part of what we do to ensure quality of the program and your experience. Apart from that, if you're afraid, as any Asian kid would tell you, our parents always ask us, you sure or not want to join the startup later, the startup totio within 3 months, you sure or not, right? Got here before? I've heard a lot, okay, in my interviews, even though it's an internship, interview, right? I had students say, my mother said, maybe not lah, maybe try the MNC, okay, real, these are real real interviews I've had. So what my team and I does is we actually go through financial, some sort of basic level of financial insurance that there is a certain runway for them to be able to then take you on for the intended period. Okay, so these are some of the things that we have put in place to make sure that it is an enjoyable program experience for you. Also, so that you can go back and tell your Asian parents that can, okay, at least for the program, the duration of the program, they will be fine. Okay. So we are looking for passionate people. If you're doing your undergraduate studies, so if you're doing a bachelor's, or if you're a master's or PhD student, we would have a project for you. I'll go into the projects a little bit later on, but if you're really interested, this is really, a good place to start to dabble into what bringing some of these technologies into the commercial world looks like. Okay. So some of the projects that you can look into are things like within the AI realm, we have a company called Nika. They're doing generative large climate model for nature purpose. So that's what they call Planet GPT. So these are interesting projects that you're working on. Within the quantum ecosystem, we have quantum, we have Entropical Labs. They're very fun people. We go climbing quite a bit, so if you have any climbers here, if you join Entropica, there we go. We will see you at the climbing. We're trying to do a bi-weekly climb. Okay, what they're doing right now is to do software error correction, so we are having people, they're looking for people to join in to work on some of these things. Okay, now, because we're government funded, the biggest questions that I get when I do a sharing like this is, you know, if I'm not a Singaporean, if I'm not PR, you know, am I eligible? The answer to this is yes. We are open to anyone from anywhere, right? So you can be holding, like, I don't know, some nationality that I've not heard of, and you can still join us in our program. So to give you an idea, we have quite a big global outreach. These are just some of the schools that we've been speaking to and some of the places that we have a footprint in. So we have gotten people from anywhere from like your EPFL, your ETH Zurich, that's where we see a lot of quantum talent coming in. We also have students coming in from Cambridge, Oxford, and some of them actually stay. So we like to quote someone from Entropica. He did his PhD in Cambridge. He came in through our program, and after 6 months, he got converted into a full-timer. So now he is the head of hardware at Entropical Labs, and he's been there for, I think, 3 years now. So there are stories like that if you are really interested to join and perhaps pursue a career in this space. Okay, I won't go through too much details about the projects. I think I spoke a little bit about some of what these companies do. If you're really interested, we can have a chat after this, or you can scan the QR code, start an account. All the information about what sort of roles, which companies have posted a role, are on the website. Everything is made clear, the requirements of what the role entails, and what skill sets are required are all found on the webpage. All right, I'm going to end with this slide. Again, I said we are not all work. There's kind of a little bit of fun that we try to inject as well. So you'll be able to meet different people from other startups, different apprentices being placed there at our orientation or graduation events. We also do have, you know, occasional hangouts. So we did a picnic the other time. I think that was last year during the National Day parade. So we were looking at, we were watching fireworks over picnic. And then sometimes we do like quantum dinner nights where we get all the quantum apprentices together to have dinner together and just to share a little bit more of their experiences and some of the knowledge transfers. So yes, it's quite a fun program. If you have any other questions, I think we will open up for Q&A and then we can chat more.
Genevieve and Desmond for sharing. We can open the floor to questions. Does anyone have questions for Desmond or Genevieve? Yes.
The question is statement. You mentioned many times in Tropical Labs, they are very nice and funny people. This is because the CEO is Italian, it's Tommaso.
Thank you for that. Anyone else? Yes.
Thank you for the sharing. I'm just wondering for both of you, what are your backgrounds and actually what got you to doing what you're doing today in your respective roles?
Okay. I like that question. So I'm actually I majored in marketing and HR from NUS, and I was I was actually telling Honor over lunch earlier. I was quite sure that I would go into marketing, and then when COVID hit, I was like, oh no, no one's really putting money into marketing. And at the same time, obviously, with any Asian family, your parents will always tell you, look for jobs where the industry is booming, right? So unfortunately, I did not qualify to be an engineer. That was not my passion. And I was then looking at, okay, tech seems to be booming. Should we look into a job in tech? And then naturally that would look something like being an HR in a big tech MNC, or doing marketing within the big tech MNC. I think that's the Singaporean dream lah, right? So that was, I think, where I was trying to go into. And then I very fortunately came upon the SGInnovate job role. And then it looks really interesting because I was not really sure whether I wanted to choose HR over marketing or marketing over HR. And this was a role that allowed me to do both HR and marketing. So I do a bit of recruitment, I do quite a bit of talks and outreaches. And at the same time, what I understood from the job was that I was able to then plug myself into an ecosystem where I was completely foreign to. Me at least like 6 months before I started having proper conversations with founders like Tommaso. Thankfully, I have met really great founders along the way who were patient enough to teach me exactly what is QKD, to teach me, what is the difference between a software stack and a particular program language, things like that. And that really helped me to realize that, oh, this is an interesting job, that I might not be an engineer, or I might not be able to say that I can discover quantum physics in published papers for the ecosystem. But I'm doing my part by ensuring that we're attracting great talent to come into Singapore, to make sure that these startups are having the right people and having the right kind of skill sets that these people come with to accelerate their product. And that's my little part. And when I see some of my founders kind of grow their teams, I see apprentices that I bring in, and I recruit for them, staying in the company and growing in the company, especially when, I have people who grow from apprentices to becoming the head of one of the teams. Those are little accomplishments that I feel makes my job really impactful.
Okay, I have a short version and I have a long version, okay? Short version is, I'm always interested in developing people, right? And long version is, before coming to this office, I was a practicing quantum scientist. I was involved in a quantum sensing project. And if I go way back, as I was telling Honor just now, back in JC days, I used to be in astronomy club. I was always very interested in science.
Vice President. Yeah. I need to highlight that.
So then, one thing led to another. I was always very interested in science back in JC. And then, never traveled out of Singapore for the first 21 years of my life, except for maybe school camps, 2 school camps to Johor. Okay, but then with quite good results, I got the A-star scholarship, and I just went on overseas. And that impressed upon me as a young adult then, that opportunity opened doors for me to see the world. And coming back to Singapore after, doing my bachelor's and then my PhD and doing science, and I was like, oh, this opportunity came up for me to come up to the National Quantum Office to try and develop scholarship schemes, to develop our people, right? And also attract people from all over the world to come to contribute to Singapore's success in quantum. So that's what drove me to my current position. Yeah.
Hello. This is a question for the two of you and anyone else that wants to come in from the audience. So in our last panel, we heard a lot from our theorists about how unknowable and ununderstandable quantum is. And at the deepest level, that may be true. But what we've heard from the two of you is that there's an entire thriving economic ecosystem in Singapore where very entrepreneurial kind of engineers and scientists have figured out how to build successful businesses using quantum computing and quantum technology and indeed quantum mechanics. So I'd like, if I could, to ask the two of you to give a couple of examples of businesses who have perhaps come through the SGInnovate program or the National Quantum Office that you think in some way are kind of flag bearers for how to turn this deeply counterintuitive science into something that's practically useful kind of within society.
Yeah, the biggest flag bearer that I usually bring out as a case study when I go overseas for outreaches would be spectral. So I think we talk about quantum key distribution. So Rob and his team have been doing great work in terms of really packaging that technology towards the government agencies. So we're seeing Spectral having clienteles, and why they're so successful and why so much investment is going into Spectral is because the encryption and decryption technology that they're having is very useful when it comes to defense. When it comes to governmental, very high confidential information that is pivotal almost to the entire society. So this is where we see things like quantum communication technologies really being that flag bearer for Singapore. They have footprint almost internationally and globally. They launched their first satellite in Switzerland, Spooky, and they've grown so much then. Their biggest partner right now, I think, is Toshiba, who's supplying some of their hardware. And we are seeing a lot of international sort of collaboration coming together to make this technology work. And I think it's just it's just heartwarming to see that this technology came from CQT, came from Singapore as a base, and because of where we are as a country in terms of politics, in terms of the governmental support that we're giving to startups, I think it's heartwarming to see that there is a market and there is support to push some of these technologies out to make sure that they are actually economically viable, and beyond economically viable, they're actually growing and thriving and leading and paving the way for a new realm within the cybersecurity space.
Okay, I wanted to say, give a bit of a disclaimer first, because as I mentioned just now earlier, our office started in 2022, right? And the scholarship we just started running since last year. So it's still quite premature in a sense to see the success cases coming out from the scholarship scheme. But when you ask the question, that which company you think is a flag bearer, not thinking in that context, and I was also thinking it's Spectral, because if you look at how should I say, their demonstration of quantum key distribution from space, right? We are, I think, the second country in the world after China in the civilian space. Don't talk about anything that God knows what the military does, but yeah. So Genevieve has covered, most of the things that I would say is features about Spectral and why is the company is such a flag bearer in this space. But I guess the key is to see, for every, and I'm going a bit broader in here, for every technology, you try and figure out what it can do, and you try and look for what's the value that you can derive setting up a company and operating that space. So yeah, I hope that answers your question.
Hi, both of you are involved in talent development. Can I inquire, like for talent, what is the most important trait or characteristic? Is it like is it vision, or is it, you know, technical ability, great communication skill, or is it just the, you know, never dying spirit to try and try again until they succeed? Thanks.
Okay, as I mentioned just now at the beginning of my talk, I'm impressed at the richness of the human imagination and creativity. And I think one recurring theme that I get from the whole how should I say, the last two acts and this current act, hopefully this current act, is resilience. I would say the obstinance, or like obstinacy, like like Valerio and Dagomir has already keep saying, we don't fully understand quantum mechanics, but they are still chipping away at it. They are still trying to figure things out. So I think, if you ask me personally, the first thing I would say is the drive. Yeah, that's one. Two, I would say, is being very open-minded. Being very open-minded, you may not come from quantum, you may come from maybe things that are adjacent. I think someone had a question about AI, right? But when you study, like, for example, bachelor, master's, or PhD, it's not about the content. It's usually about the skill set and the training of the mind that you can move from topic to topic. Yeah, I give a bit of personal example or history. I started with a Bachelor of Physics, and I moved to a PhD in chemistry. But my interest in chemistry was in this field that was about a decade and a half ago, that they were looking at. There was questions whether there were non-trivial quantum mechanical effects in photosynthesis. I was very interested in that then. So I moved into that area, and I was like, okay, I'm a physicist moving into chemistry. In the beginning, it was quite tough because the chemists use a slightly different set of nomenclature, especially in physical chemistry and chemical physics. But I was persevering. I was like, I'm bloody interested to know what's happening in photosynthesis, and if there's quantum mechanics involved. I was like, okay. So it took me about a year and a half to finally realize, oh, that's what they're talking about all along, and what those nomenclature means. Right? And yeah, so I personally believe in, if you are bloody interested, you really want to find out more, you just do it. Nike don't sue me, but you just do it. Right?
Yeah, I agree with Desmond, but if I could add on, I think it's really looking at actually what kind of space you want to be working in, right? I think if you're looking at doing quantum in an academic setting, they're looking for completely different talent. Beyond resilience, I think it takes a bit of craziness, I'm sorry, but I really think so. Yeah, but I mean, if you're talking about working in a startup, I think a lot of my founders, what they're talking about is initiatives, right? The base that we assume for all talent that comes through our door is that people are intelligent, people are smart, and I've seen so many smart people. So, like qualifications, smartness, hardworking, those are basic assumptions, right? But beyond that, it's taking the initiative to say, oh, if I look at this problem that the company is discussing or that they're talking about, or I see certain things that are coming out in maybe a neighboring adjacent technology or startup, how does that relate to me in where I am here in my job, in my current position? And then kind of seeing if can we sort of like look and see if it will affect us, maybe not today, maybe in the future, and then prevent that from happening. So doing a little bit more predictive analytics, right, almost. And then taking initiative to say, where are certain gaps? Before even the founder comes to you and say, okay, we have a problem, we need to fix these are the bugs that we have found. It's going in to say, actually, I've really had a sensing that these are some of the problems. Maybe we should prioritize some of this, and then we can work on some of that. And that is what a lot of the startup founders that I've spoken to appreciate and look out for in a talent, especially when they have a pool of really great and very smart people. I think being able to take initiative, problem solve, and seeing some of these patterns on your own sets you apart from any other talent.
Maybe we have time for one last question, if anyone else has a question. Okay? No? Okay, I think with that brings us to the end of Quantum Conversations for today. We hope you had a good afternoon learning about quantum, its place in our world today, and how artistic mediums can raise awareness and even enable their education. I'd like to share the museum's thanks to all our speakers, our program collaborators, the Center for Quantum Technologies, National Quantum Office, and the Singapore Week of Innovation and Technology Switch, our colleagues Haziq, June, and Neil for their help with production, Liana, my right-hand woman, for today's program, and also our colleague Sue, who is working in front of house. The speakers will be hanging around for a little bit if you have any questions for them. So feel free to approach them after the program. But if that is all, thank you so much again and have a great rest of your day.